Hello everyone, welcome to the NN Classroom. Today, I'd like to share with you a past paper question from 2018, time zone 0 in November. Question number 18, a classic question from topic 6, kinetics, or we call it the rate of reaction. Let's see. Samples of sodium carbonate powder, so we call it Na2CO3, really famous carbonate substance, were reacted with separate samples of excess hydrochloric acid. Keyword from the first sentence is that these were excess, which means the hydrochloric acid now is in the amount that more than enough. So which also hidden meaning behind is that the sodium carbonate, these will be what we call the limiting reagent. This is a really important concept because what limiting reagent will do is that it will affect all the stoichiometry for the product, or in other words, the amount of the product that you are going to be produced will be limited by the amount of limiting reagents that you add in, but not the excess reactant. The excess this time is the hydrochloric acid. So I underline it. So that's why the hydrochloric acid will not be influencing the amount of product that I'm going to have at the last step. This is important. Let's see for the two reaction conditions, right? The first one is that we have 1 grams of the sodium carbonate added to 0.5 mole per dm cube concentration of the hydrochloric acid. For reaction 2, having the same mass of 1 grams of sodium carbonate, but added to 2 mole per dm cubes with a much higher concentration. So what's the perspective between reaction 1 and reaction 2 is that the concentration is increased, right? The concentration of the reactant is increased, but the amount of the limiting reagent stayed the same again, but the amount of limiting reagent stays the same. This is really critical. The second message and the first message. The first message is the concentration of the reactant is increased. But the second message is that the amount of the limiting reagent is staying the same, which means all the product will also be the same in terms of the product yield. Because, again, as mentioned, limiting reagent will decide how much that I will be getting at the last step. So that's why if they're asking, what will be the same for the reaction? I use a red color, same for the reaction, which means all the things about stoichiometry at the final step. So in this case, which is the mass of the CO2, so something to do with stoichiometry, right, will be staying constant because the amount of CO2, no matter CO2 actually, even if you're asking for sodium chloride or water, all the amount will be subjected to the moles of the limiting reagent that you plug in. So in this case, as we have the same mass of the sodium carbonate, the limiting reagent that to start with, so which means the moles of the limiting reagent are constant, so the moles of the product will be constant, so all the stuff about product will stay constant, right? But what really it is inferencing is that really we are doing something change, but changing the concentration of the reactant. So as you know, concentration affecting more likely about the rate of a reaction. So obviously we should expect the rate of the reaction for reaction 2 will be faster than reaction 1. So that's why the initial rate will not stay the same, but in fact reaction 2 faster than reaction 1. And also with the initial rate to be faster, you have an early time to finish the reaction. So that's why C, as having a really strong relationship with A, will not be the answer as well. And also with the rate of production of CO2, no matter initial or final, still will not be the same, because if you have the different initial rate, it is quite difficult that overall speaking you're having the same average rate. So that's why obviously the answer this case will go to B.